Hello, and welcome to this week's episode of Instant Insights. This week, the wonderful Martina Raveni will be chatting to Stefan Hrabar, CEO and co-founder of Emesent, a LiDAR mapping and data analytics solutions provider that aids the mining, engineering, and public safety sectors in their operations. Together, the two will discuss what Emesent does, the challenges it is helping the mining sector to overcome, some real-world use cases, and lastly, how the future of mining is going to look with the help of automation. This is a really great episode, and getting Stefan to come onto this podcast is a real coup. So with no further ado, I will leave you in the capable hands of Martina Raveni.
Hi, Stefan. How are you?
I'm good, thanks, Martina. And thank you for the invitation to be on the podcast.
No, thank you for joining us. So I will start directly with the first question. And can you tell us a bit more about the story behind Emesent? So what inspired you and your co-founder, Farid Kenjoul, to create this company, and in general, what Emesent actually does?
Yeah, sure. Well, first of all, I think I love the name of the podcast, Instant Insights, because that's kind of what we do, and what we're trying to do for our customers is to provide them with instant insights, except we do try to do it autonomously. So we use autonomous systems to capture data, which is then used to derive insights as quickly as possible. So yeah, no, very relevant name for the podcast. But to go back a bit more, to cover more the kind of the origin story. So yeah, you're right. I mean, I co-founded Emesent with Farid, and prior to this, we were both at CSIRO, which is the robotics or the research organization in CSIRO, which has a robotics sort of division, and we were in that division doing research on robots, specifically on drones, and making them more autonomous, adding sensors and computers to drones, going back more than 20 years ago, I guess. And then one of the things we managed to solve is using LiDAR on drone to allow the drones to navigate in areas where there's no GPS, like in underground mines, and use that LiDAR data to also generate 3D maps without using GPS. And we saw there were a lot of potential in different areas for using this technology. So we formed the company to commercialize that technology and started focusing on the underground mining space. So essentially, yeah, we're a software company. We develop advanced scanning hardware as well called HoverMap, and that's used to help navigate drones and other robots autonomously in these underground environments, and then provide those operational insights in these high-risk sort of time-sensitive environments. So yeah, trying to use autonomous robots to provide instant insights.
That's great. I will follow up on what you just said about the GPS denied environment. So we know that mining exploration is notoriously challenging, especially in this underground environment that is arduous, hard to reach, and no GPS arrives there. And mapping is paramount to ensure, for example, accurate survey grade results or calculate the volume of mining material, all this kind of stuffs. And either ground or underground mapping of the sites is required. And your company operates in this kind of environment. So my question is, what are some of the technical and operational challenges that you are facing, or in general, how you're helping this sector to overcome all this?
Yes, I mean, like you said, underground mining is a very challenging environment. And from the mine's perspective, some of the challenges they have is, like you said, they need to capture up-to-date data of the mine as it evolves. Obviously, as they keep developing the mine, it's changing, so they need to try and measure those changes, and also measure to see if there's any problems or issues that are arising, if there's movement underground, any risks that they need to be aware of. So yeah, there's a big challenge of collecting accurate data regularly, but doing so in dangerous places. I mean, obviously there's part of these mines that are just very inaccessible, and you can never send people there because it's just too dangerous, but they still need to capture the data. So that's kind of one of the key challenges that they face. And the challenge for us to solve that problem is to operate in that environment with a robot. So usually robots, if you're operating, or drones, for example, are operating out on the surface, you can rely on GPS so that the drone knows where it is and where to fly. But once you go underground, there's no GPS, so it's very difficult for a robotic system to navigate, obviously through fairly small tunnels with a lot of obstacles. So for us, the technical challenge is allowing a system to navigate intelligently in that environment. And like I said, we do that by the use of LiDAR. So that's a laser-based sensing technology, and we process all that data in real time on board the hover map system to allow that navigation underground. Yeah, so a lot of challenges for the mine and to sort of provide a solution technically.
Also, I'm thinking, sorry to interrupt you, but I'm thinking about safety. That is one of the top concern of the mining industry, and especially, tell me if I'm wrong, but when we have, for example, a collapse or for a seismic event or whatever could happen, you use your technology, and that's increase the safety because no people are necessary there because you go with your hover map.
Yeah, exactly. I mean, obviously, mining industry is very safety conscious. It's a risky environment, so they're concerned with safety. So one of the best ways to make it safer is to keep people out of those environments. So that's where robotic systems help. So we definitely help with safety there by sending in robots instead of people. And then the secondary sort of safety impact is with the data that the system has collected, they have a better understanding of that environment, so they can help to detect if there's something going wrong earlier and resolve that. So like you mentioned, or if something has gone wrong, then you can investigate that without sending in people. So if there's been a seismic event and part of the mine has collapsed or is not stable, instead of sending people in there to go and inspect it or make sure it's safe, you can send in robots to go and collect data and make sure it's safe, and then reopen that part of the mine quicker or sooner and sort of start production again. Obviously, that's very valuable to the mines
and reduce downtime.
Exactly. Yeah.
No, that's great. And I mean, let's stick to mining. I know that Emesent operates in various industry, mining, construction, inspection, but stick to mining. So you touched them, but can you tell us a few real world with companies, possible use cases where your technology made a significant impact and what kind of results you've achieved?
So I mean, we often hear good user stories from our customers where our system has saved them. Sometimes it's just valuable minutes, and every minute in an underground mine in operation when you're stopping production is very valuable. I heard a story recently from one of our resellers who was talking about one of their customers using our system where they were mapping stopes. That's the cavities formed underground. And usually the important thing about the stope is the total volume, because that tells them how much ore or how much material they've extracted, but also how well the stope has gone versus the design. So they design the shape of a stope based on the size and shape of the ore body, and then they blast and then they extract the fragmented material. But sometimes that blasting doesn't go quite according to plan. So they might be overbreak or underbreak. So if there's overbreak, they blast away material that they didn't intend to, and that dilutes the ore. So you get lower grade ore. Underbreak means they're leaving high quality ore in the ground, and obviously that's not good either. So when they were first looking at the statistics around the stope, they were focusing on the total volume, and the volume was almost exactly like it should have been. But then when they started using hover map data, they could more accurately compare the actual shape of the stope to the design, and they realized that there was, say, 25% overbreak and 30% underbreak. So together, those 25 plus and 30 minus gets to about 5% of the total volume. But because there was such a huge amount of overbreak and underbreak, they were diluting the ore and leaving ore in the ground. And they realized that was obviously costing them a huge amount. And they calculated that around 2 hours use of our system was their return on investment. So it paid for itself in around 2 hours, just based on that overbreak, underbreak, and being able to do better reconciliation. So they can use that data then to identify what's causing the overbreak and underbreak. Is it the drill and blast pattern that's wrong? Is there some geotech structures that are sort of interfering with the blasting? And then adjust or adapt the the next round of blasting to try and get a better stope shape. And they obviously try and improve the overbreak, underbreak problems.
And my very last question comes when we already had the opportunity to chat before, and it's about the increased level of autonomy in the mines that we're seeing. I'm thinking about autonomous robots on the ground that are capturing data, and autonomous drilling or loading explosive, blasting, excavating, so all this kind of stuff. And then you have around or fixed or movement sensor monitoring the environment. And then all those data, also from Hrabar, for example, are collected and streamed to a cloud and maybe analyzed by AI to actually make decisions. So I'm seeing an increased level of autonomy in the mining sector that's completely reshaping the way mining works. So I would like to ask you, how do you envision the mine of the future?
Yeah, I mean, this is what excites me as well, is just to see the impact that, like you said, autonomous systems can have at the sort of full mine site scale. And for now, we are quite kind of getting familiar with individual bits that are becoming autonomous or automated, like underground boggers or on the surface haul trucks. But eventually, as you start adding more and more autonomy to these bits and pieces, our vision of the future is that the whole mine becomes an autonomous system. Like you said, you've got this fleet of systems underground that are doing the work. So they're drilling or blasting or hauling ore. At the same time, they've got sensors on board that help them to do their autonomous navigation, like LiDAR. That sensor data can also be used to update a model of the mine. So basically update a digital twin of the mine, on a daily basis, together with any other sensors that are down there. So our vision is that sort of data collection is automated through robotic systems, fed to some central place where it's stored, analyzed, insights are derived, and then used to sort of close the loop and decide what to do next in an optimal way. So eventually that whole system becomes autonomous with maybe humans, what they say, sort of sitting on the loop, not in the loop. So humans are supervising the system. And obviously that can drive to a lot of optimizations and efficiencies. And I think, that's sort of the exciting part for us, is like the role we can play in enabling that while working with others to sort of provide that full autonomous digital mine solution.
Thank you very much, Stefan, for those instant insights, and thank you all of us for listening. And from us in Thematic Intelligence, see you next time.